So much to think about. Let's see, we've got everything. I see the red border. I see the recording notification and right here as well. So I think we're good. And that also reminds me, because I sometimes get real involved in what I'm talking about, that also reminds me to take screenshots of the attendance. So let's take care of all of that right now. There we go. Thank you so much. Let's go back to Alex now. Let me just get back up a little bit. So here's our Alex course, your Alex course here, and it's telling you what's up next. And we are going to talk about, this is what we're going to talk about today, this objective that's due this Sunday, 11:59 p.m. This Test 3 review, no credit assignment, 25 questions, same 25 questions that is in the Test 3 review objective in Alex. The problem with the Test 3 review objective, and I should say potential problem, is if you haven't learned a topic yet, it's not going to appear in that Test 3 review objective. So you then, what this is good for is all 25 topics appear here, all of them. They're not going to not appear for any reason. They all appear for every student in this class. Students who tend to do this Test 3 review, no credit, or who do the Test review, no credit assignments tend to do quite well in the class. It's just another way to review. And what's nice about this assignment is that it has the 7 written work required problems, has the first 7 problems. So you know right where they're at, and you can go there and look at those problems. So I would encourage you to definitely do that assignment. The 7 written work problems are also going to be the first 7 problems on your actual test. So there's some information about Test 3 here to remind you. It opens at 11 a.m. and it disappears at 4 p.m. Now let's go and talk about how do you review learned topics in Alex. And feel free to ask me questions at any time. I want you to understand how Alex works, as well as understand the topics that we cover. So if you currently have a topic that is Alex considers you have learned that topic, then here is where you go to review that topic. Now, what I would recommend here is you see the learn, if you click on those 3 horizontal bars, the main menu, you see home, which is where we just came from off the pie. We just were on the home screen. I clicked on the 3 horizontal bars and you can see learn. That's where you go to learn topics. Once you have learned those topics go to review mode. Now, it is possible to unlearn a topic on a knowledge check, and then it will go back. It may go back to learn mode, especially if it's a prerequisite for another topic. So learn mode and review mode work the same, but let me just show you review mode for a moment to make sure everybody understands how to navigate it. I click on review mode, and there's this drop down here. I'm going to click on it. And then you see review mode up here. I'm going to click on that, and it's got all of the objectives. And you can click on whatever one you want to work on or review. Let's say I want to go to the test 3 review objective. And this is the ones I've got in review, the only ones I have in review mode because I have this set a certain way, but you can see test 1 review objective up here. Now, if you want to go back up here and click on something else because you want to go somewhere else, you want to look at what and see what you which one you can review, and in this objective, zeros of polynomials, you can click on that, and that would be multiplying expressions involving complex conjugates. So that's how that works. If you want to go back to learn mode, you want to click on these 3 horizontal bars and then click on learn mode. And then, of course, you will need to find whatever, same thing, use the drop down to figure out wherever you want to go in learn mode. Any questions on that? Does that make sense? I hope it makes sense to you all. I did have a student question about that, and I wanted to talk about that. Now, also, what I want to talk about, and I have had some students who have been doing this, is if you complete the current objective early, you can go back and work on past due objectives, or you can go forward for that matter. But you can only go back and work on past due objectives until the current objective, until the deadline of the current objective. So for that, that is usually Sunday night for us. Let's say the current objective that we're going to look at today, you finished that early and you've got leftover time, and you can then go back and work on past due objectives until Sunday night at 11:59 p.m. When the new objective opens up, you cannot work on past due objectives or past due topics anymore until you finish that new current objective. So if you wish to do that, which some of the students have, then you will need to send me screenshots of assignments in ALEKS, of the assignments which have changed. So while I'm here, let's take a look at that. So let me go back into the student view and take a look. I have no idea what I'm going to find in the student view when I open it up, but that's okay. It's just my play space here. You want to click on assignments here, not gradebook, assignments. And then any of these ones that I need to change, say you got 100% here, you want to make sure you're sending me a screenshot of it. I cannot see your assignments view in my ALEKS course. And that's where ALEKS is changing the objectives when students go back and work on them. And it should be in the grade book, but they're not doing it that way. They're doing it in assignments. So any questions on what we just talked about? Any questions on ALEKS at all? I'm just going to check in here. Oh, yeah, you're welcome. You're welcome. So any other questions about ALEKS? So let's get started here. So if you have your graphing calculator, that's great. If you have it handy, please take a minute or two to go grab it because we're going to use it a lot today. And I want to just encourage you all to be active in the course. So I'm going to go down to my desktop right here. And let me get back up to the beginning. I didn't have as much time as I would have liked to, but between classes. And what we want to do is this very, very first topic here. I looked at my ALEKS reports. This is one of the written work required topics for test 3. Test 3 written work required topic. I wanted to cover this topic with you today, and I'm doing a different question than I did before because number one, the results in ALEKS are lower than I would like to see as far as students who have gotten credit for this topic, who have learned this topic. And number two, it's a very great segue into what we are going to do today. So this is one of the written work required topics that you are going to see on Tuesday. So feel free to ask questions. No question is too small. I do not want one little thing to hold you back. I was talking to a trig student. Well, I had a conference with her. She wanted some help outside of class, and so I had a conference with her last night. And she said, I love working with you so much because she took me for ALEKS and now she's in trig. And she said, you know, you let me ask simple questions, and I feel very comfortable with you doing so. And really and truly, that is the way I want it. I want you all to feel comfortable asking simple questions, because one little simple question that you get answered may give you credit on an entire problem. You don't want one little roadblock to stop you from surging in this class. And so please ask questions, especially about this one, because it's a written work required topic. So let's take a look at this one. Using a given zero to write a polynomial as a product of linear factors, real zeros. This means we are not talking about complex zeros that have an I in them. So let's look at this. So if you have any questions about synthetic division, we're going to be using synthetic division extensively today in literally almost every problem. I can only think of one where we won't be using it. So it's very nice that we are told that we have a zero. We have a cubic here. The highest power is degree 3, because when we divide that cubic, in synthetic division has just been changed into adding a negative, basically. So when we do synthetic division, we really divide by an x each time. Each synthetic division we do, we divide by an x each time. So 1, 0, this -1, is going to allow, and putting it through synthetic division, is going to allow us to go from a cubic down. If we reduce the power by 1, we would get a square down to a square, which is known as a quadratic expression. It's going to allow us to go down to a quadratic expression. Well, we can then use the quadratic formula to solve that. So that's what our goal is, really. We want to get down to a quadratic. So we're told that -1 is a 0. So we put -1 out here. Remember, a zero is an x coordinate that makes y equal to the number 0. So the zero is up here. It's our x. Over here, we get a y equal to the number 0. In each synthetic division we do, when we know we have a 0, that's what happens. So let's look at this. The coefficients across the top, we have 3, 2, x to the first, the constants degree 0. They're in descending power order, and we have them all, so we won't have to use any 0 placeholders. So our coefficients are 1, -5, -4, and 2. Across the top like that. This looks like a division symbol. But synthetic division has been, all the theory is great, and we have mathematicians figured out how to make synthetic division positive while preserving the mathematics. So we want to go through the synthetic division process. So the first thing we do is drop this first number straight down, which is a 1. And then we go through a sequence. It's drop, multiply, add, multiply, add, multiply, add until we're done. So we drop this. Now we're going to multiply. This number here out in front is always going to be involved in the multiplication. It's -1 times what's at the bottom of the previous column, which is 1. That's -1 times 1, which is -1. That -1 goes right here. And then we add straight down. -5 plus -6. Oh, sorry, I got ahead of myself. -5 plus -1 is -6. And we just did our addition. So now we multiply again. We take this number, -1, put it here, or wherever you're doing your scratch work. -1 times what's at the bottom of the previous column, which is -6. That's +6. That went up there. -4 plus 6 is 2. Now we multiply again. -1 goes over here. And then what's at the bottom of the previous column is a 2. And -1 times 2 is -2. 2 plus -2 is 0. And we needed to get the number 0 here. If we did not, we've made an error because we were told that -1 is a 0. That means -1 is an input that gives us an output of the number 0. Any questions on the synthetic division? If we were doing this long division, you may be able to see something better, but really what's going on here when we divide by this single 0 is this power of 3 is getting reduced by 1, and now we are left with the coefficients of a degree 2 polynomial, which is a quadratic. And since these are the coefficients here of a quadratic, we can use the quadratic formula. And that's if you want to make sure you're taking and writing those A, B, and C down. You want to split this last number off, which is why I usually put a vertical bar here. If you've done that, then what's left here are the coefficients. On this side are the coefficients of a quadratic. So at this stage, we can go and find and use the quadratic formula to find our other 2 zeros. The quadratic formula is going to give us our zeros. And the reason why is because we are reducing this power by 1 each synthetic division that we do. So this 3 goes down to a 2. And this is really the coefficient of the x squared term, the x term, and the constant term. And what we are asked to find are the linear factors. Well, how are linear factors and zeros related? So and this is how they are related. They are related by the factor theorem. X minus each zero is a factor. So the quadratic formula is going to give us our other 2 zeros. And how we find those other 2 zeros, we're going to use this quadratic formula. So let's start with x equals negative b. What's our b? Negative 6. Plus or minus the square root of b, negative 6 squared. Minus 4, our a is 1, minus 4ac, and our c is 2. All over 2 times a, which is 1. So let's work with this radicand inside the square root, discriminant, whatever you want to call it. And negative 6 squared is negative 6 times negative 6, which is positive 36, minus 4 times 2 is 8. 36 minus 8 is 28, and we can break 28 down into 4 times 7. So square root of 28 is the square root of 4 times the square root of 7. The square root of 4 is 2. So we get negative times negative 6 right here, plus or minus 2 times square root of 7 there, 2 times 1, which is 2 right there. You can't cancel these 2's because this 2 is participating in a term. We cannot cancel terms. We can only cancel factors. And I think I've said this many times, but that's why we spend so much time on factoring, because we can cancel them. We can cancel factors. So this 6 I wrote as 2 times 3 because we've got a 2 here and here, and I'm going to factor that 2 out. So I'm going to factor 2 way out in front. If we do that, we've got a 3 left inside, plus or minus this 2 went way out front. We have left a square root of 7. So we've got a 2. We've got 2 times this up here, and downstairs we've got 2. So please, every time you cancel, make sure you know why you are canceling. So here, this is 2 divided by 2, which is 1. 1 times what's left is what's left, because 1's the multiplicative identity. So these are our other 2 zeros. We were asked, however, to write the factors. Express g of x as a product of linear factors. We've got 3 zeros. This 3 here tells us we've got 3 zeros. Occasionally, a 0 may be repeated, but this tells us how many zeros we need to count for. And to each 0 corresponds 1 factor. So it also tells us how many factors we need to account for. So by the factor theorem, x minus each 0 is a factor. So this one up here, this is one of our zeros, negative 1. We were given negative 1 is a 0. So x minus that 0, negative 1 is a factor. X minus another 0, which is 3 plus negative, which is 3. Let's cover up the negative sign. So this x minus a 0, and let's cover up this minus sign. So another 0 is 3, or a second 0 is 3 plus square root of 7. We are required in ALEKS and in math in general to have parentheses around each factor. That's those parentheses. But because we're talking about a 0 here with 2 terms, and we want to make sure that we have the sign noted correctly, we need to put parentheses around 3 plus square root of 7, which is the 0 as well. And then we have that x minus each 0. We have a third 0 is another factor. Our third 0, we cover up the plus sign, and we have 3 plus square root of, we have 3 minus square root of 7, and we're going to put parentheses around that 0. So make sure you've got parentheses around all of your factors and parentheses around each zero that has 2 or more terms. You won't see one with more than 2 terms. Any questions on this required written work topic that you will definitely see on test 3? So no, you're not necessarily going to get this one. I suppose it's possible, but not likely. I hope this all makes you feel better about this topic. That's what I'm trying to do. I'm trying to get some more students to understand this topic. I notice a lot of you are doing quite well on a lot of the topics, but I wanted to do this one. Any questions on this particular topic before we go on? And that is, we're going to now next start the objective that is due this Sunday night. This is the only topic in this objective that is due Sunday night that doesn't involve zeros. So I want to take a look at it first. It's a nice little warm-up. So what we want to do here is the reverse of factoring, multiplying. So we want to take this factor and multiply it times this factor. So you notice we've got, this is x minus a 0, 3 minus 2i. This is x minus a 0, 3 plus 2i. Rather than having parentheses or on the outside here and here, we've got brackets. It's the same, it's exactly what we were looking at before. We need parentheses around both, or brackets for that matter, around both the factor and also the 0 if it has 2 or more, if it has 2 terms. So we want to multiply this up. So what I did is, we're just going to use a multiplication table to do this. Down here, I put the terms in here. So the first term is x, and then we have minus 3. If we distribute this minus through, we get minus 3. And then minus a minus 2i is a plus 2i. And then what I did is I did the same for the second factor, but I put them across here. X minus 3 minus 2i right there. And we are now going to treat this like a multiplication table. So to find what goes in this first box here, we want to go straight over here and straight up here. So if we go straight over here, we get x. If we go straight up here, we get x. X times x is x squared. If we want to find out what goes in this box here, we go straight over and get x. We go straight up and get negative 3. So x times negative 3 is really negative 3x. To get what goes in this box here, we go straight over to get x. We go straight up to get this, which is negative 2i. This expression, negative 2i. So negative 2i times x is negative 2ix. That's the way we usually write it, with the variable at the end. Next row, same thing. Go straight over, get negative 3, go straight up to get x. Negative 3x we have. Here, negative 3 times negative 3 is positive 9. Here we get negative 3. Here we get negative 2i. Negative times a negative is a positive. 2 times 3, or 3 times 2, is 6. And then we have an I. Down here, to get what goes in this box, straight over, 2i, straight up, x. That's 2ix. Here, straight over 2i, straight up, -3. -3 times 2 is -6, and then we have an I here, so it's -6i. This box, just this number, this first number here, straight over 2i, straight up, -2i. So that's going to make it a negative since we got a single negative. 2 times 2 is 4. I times I squared. So right here, I squared, we talked about this earlier in the course, I squared is -1. So I took out I squared, replaced it by -1. Now we have so this -4 got copied down. So we have -4 times -1, which is +4. So really what we have in this last box here is the number 4. So let's see why I crossed out what I did. So the first number I crossed out up here, -2ix. Do we have a +2ix anywhere? We do right here. So that's why I crossed that out. This 6i, do we have -6i? We do. We add those together, we get 0. And we got 0 here too. So I cross those out. Those are just 0. So they aren't going to contribute at all. So now let's go and see what we can do. So I copy down this x squared. -3x, there's a -3x here. That's a total of -6x. I copied that down here. And then 9 plus this, the 9 from here, and then this +4 from here. So this was a +9 +4. X squared minus 6x plus 9 plus 4 is 13. That's the answer. X squared minus 6x plus 13. So there are other ways to do this. If you could actually FOIL here if you know how to do it. It's a little trickier to FOIL in this situation than most of us are probably used to, but you can do it that way. I think over the years I find students prefer this way, so that's why I present it this way. Any questions on this topic? So we're now going to start using the graphing calculator, and we are going to use it in more than one way today to find actual zeros. Using the rational zeros theorem to find all zeros of a polynomial, rational zeros. So rational zeros are just an integer fraction where you've got a nice number upstairs and a nice number downstairs. And so they're integer fractions. Integers are 0 and all the counting numbers and all the negatives of those. So they're nice fractions. That's really what rational zeros are. They're nice fractions. So rationals means nice fractions, and zeros, we know what that is. It's an x coordinate that makes y 0. So the first thing I want to do is I want to look at this function. I want to put this function in our graphing calculators, and then I want to show you how you can use the graphing calculator to possibly find a zero. It's not going to work all the time, and I'll show you why that is. So from the graphing calculator, it turns out that 3 is a 0. Remember, a 0 is an x coordinate that makes y equal to the number 0. Often, more often than not, zeros are not the number 0. So I'm going to copy down our function. I am going to then show you how to enter it in your graphing calculator, how to set your table in the graphing calculator, and how to look at the table in the graphing calculator to possibly identify any ZEROs. And it's not going to work all the time because we have to set our x's to go up and down by so much. And we're going to set that at 1. And if it's anything, and it's impossible to set it at every possible real number, so it won't work all the time. So I'm going to copy down our function here. F of x equals 4x cubed minus 16x squared plus 9x plus 9. 4x cubed rather, 4x cubed minus 16x squared plus 9x plus 9. I just want to make it sure that I've got that copied down correctly. And let me just check on you all. I want to make sure I'm recording. So if you need to go look at the keystrokes, you can in the recorded video. The videos sometimes take me overnight. It all to actually post them in Canvas in the video library, because YouTube is getting used a lot right now across all over the world. So sometimes it's rather slow, especially for longer conferences like ours. So let's go take a look. You are recording, so I'm very happy for that. Let's go look at the graphing calculator emulator. And let me first clean up from my last class. You can see I'm looking at a table here. I'm not sure if there are any zeros in there or not. Perhaps there are. If there are, let me just try something here and see if it will let me go this direction. If there are any zeros here. There. Hopefully it will stop. I might have been going too fast. Good. So I see a 0 here. Remember, a 0 is an x coordinate. It's in the x column. A 0 is an x coordinate, and I got ahead of myself. I'm right here. A 0 is an x coordinate. That makes yz equal to 0. A 0, ZERO, is an x coordinate that makes y equal 0. So the 0 is a 2 here. We have a 0 of our 0, ZERO is a 2 here. There's also another one that I saw. I don't want to go back too fast. There's another one. -7 is a 0 because it makes y equal to the number 0. So you want to be looking in the x column for zeros. And you want to look in the x column and then glance over to the y column and see if you see the number 0. So that's where we're going, and we're going to learn how to enter the function. So let's clear up the calculator as much as possible. I'm going to do a second mode to quit, just to center myself here. And what we want to do is now enter our function. To enter a function, these are the graphing keys, the graphing. All of this is really related to graphing up here. Both the gray keys on my calculator and what's above it. So I want to click on y equals. We want to clear out that function there. And the best way to do that is click on the clear key over in the rightmost column, right under the arrow keys. It will turn red. So every keystroke I click on do today will turn red. So I cleared that up. Now let's enter this function. 4. 4 turns red. X is right here. Turns red. And then we want to raise it to the 3rd power. So that would mean use this mountain peak that's right here. That will give you a box where you can type in an exponent. And we want to type in a 3. This is a step I sometimes forget. Notice the cursor is in the exponent. We need to get it to come out of the exponent, so we use a right arrow key here. Minus 16 x Mountain Peak 2. Right arrow out of the exponent. Plus 9x plus 9. And I'm going to double check. Good. Any questions on how I entered that polynomial? So let's go on. So what we are looking for are the zeros. So the next place I want to go is this table set. I want to make sure all of your tables are set correctly, because if they're not, they may not be if you're using it. If your calculator has actually gone through a few people or whatever, so I want to show you how to do that. Now this table set's above a key, it's above the window key, and the table set is in blue, so I have to click on the blue key first. It may be a different color on your calculator, and then click on the button below table set, which is called window. So you might want to jot this down. I really want this table start to be at 0. It looks like it's at where I left off last time in the table, but I don't want that. So let's see what happens if I put clear here. It will clear it off, and I am just going to put a 0 there. So you might want to copy down that setting, those settings there. 0, 1, auto. If it's not set like that, if these are asked, it's not going to work like this. It'll work, the table will work completely different. So that's what we want our table to look like. If you don't use the table on the graphing calculator, and I do not believe that it works like this in ALEKS, where you can identify zeros and so forth. I think that they've got their system where they want you to find all the possible zeros and so forth, and then try to figure out which ones to use. And I don't think that they're using a robust graphing calculator in this situation. So it's really important to understand what I'm doing here. And also, if you go on to more math classes, you want to make sure you know how to use the TI calculators, because not all of I'm the only one that teaches using ALEKS in our department. And ALEKS is in pretty wide use across the country, but ALEKS doesn't have, for instance, they don't have an ALEKS course for calculus. They have one for trig, but not for calculus. So that's why I want to make sure I'm showing you how to use the graphing calculator. So this is how we want our table to be set up, ideally. If this table starts off a little bit, it's not going to hurt anything. You just might have to scroll more. Now I want to go to the table. Tables above, T-A-B-L-E over here is above the word graph. So this table is in blue, so I know to use my button of the same color first, and then click on the graph key below it. And we want to look for a 0. What is a 0 here? What's our Z-E-R-O here? Can anybody tell me? What is our 0 here? What is our X coordinate? What number in the X column has a corresponding Y value of 0?
3.
Yes, 3. Very good. It is 3. So 3 is our 0. So we've identified a 0. So 3 is our 0. So let's go back here to the presentation here. And I just wanted to show you how you could use the graphing calculator to determine 3 as a 0 in this case. And how could you use it in the future? So that's the first thing I did. And let me just go down a little bit. The next problem we are going to do, we tried it on the graphing calculator, and we were not able to find a 0 quickly. Here are the zeros. And the reason why we couldn't find it quickly is because it's -5/7. So some of them you can use the graphing calculator for by looking at the table. Some of them you can't. There's another way that the graphing calculator might help you in those cases. So we found our 0. We found a starting 0 anyway. And so we're going to use it and do synthetic division. We put our 0 outside the synthetic division tableau here, outside of this division sign, although synthetic division allows us to add. And the coefficients across the top, 4. I'm looking for 0 to see if we need any 0 placeholders. 3, 2, 1, constant, good. So 4, -16, 4, -16, +9, +9. So let's do this synthetic division. Drop the 4. And now we do multiply, add, multiply, add, multiply, add. So our multiply always involves this number, 3, times what's at the bottom of the previous column, which is 4. 3 times 4 is 12. Add straight down, get -4. Multiply. 3 times -4 is -12. Add straight down, get -3. It's a little light there, but I think if you can still see, it's -3. Multiply. 3 times -3, -9. Add straight down, we get the number 0, and that's what we needed. Remember, we actually found an ordered pair that's on the graph of our polynomial. It is 3, 0. And we could also write this as f of 3, because when we get this right here is the y coordinate. The 0 is the y coordinate when x is 3, and that is 0. So there's a lot of little things about synthetic division that make it nice. So we want to find, just to be clear, we want to find the zeros. We need to check if we want zeros or factors. A lot of the process at the beginning is the same. And so we know we found this 0, so x minus a 0 is a factor. So x minus this 0 of 3 is a factor. We started with a cubic. We did a division. Really, division is, we didn't subtract, we added a negative, if you want to think of it that way. So when we do that synthetic division, we decrease this power by 1. The highest power you see, it goes down by 1. So we are now, 3 minus 1 is 2. We are now down to a quadratic term here, or a quadratic, let's say quadratic expression here. So this 4 is actually the coefficient of x squared, -4 is the coefficient of x, and then we have our constant. You can put this little vertical line and go backwards if it would help you. Constant x squared. So I've labeled these with also A, B, and C, just in case we need to use a quadratic formula, and we will need to use it to find the other 2 zeros. So x minus the 0, 3 is a factor. The other factor is 4x squared minus 4x minus 3. So we want to see the next page. And what we really want to do here is set this factor equal to 0 and solve for x by using the quadratic formula. And let's identify our A. Here are A, B, and C. So A, B, and C are 4, -4, -3. 4, -4, and -3. Let's use the quadratic formula. X equals -b, which is negative, this negative, and b itself is -4. Plus or minus square root b, -4 in parentheses, because we need to square the negative sign. So -4 squared, minus 4, a, 4. C is -3, all over 2a. A is 4. So let's just work with this and see how well we can clean this up. -4 times -4 is +16. Minus times a minus is a plus. 4 times 4 is 16 times 3 is 48. 16 plus 48 turns out to be 64. Square root of 64 is 8. So this is equal to negative of a negative is a +4, plus or minus this 8 over 2 times 4, which is 8. So let's write this as two different solutions, or two different zeros. Mean the same thing, really. So this is, let's just do the plus one. So if we cover up that minus, we get 4 plus 8 over 8 here, comma. If we cover up the plus sign now, we get 4 minus 8 over 8, this right here. So if we look at them individually, we're going to get 4 plus 8, which is 12, over 8. So this reminds me, I want to remind you all of something that's very handy to use on the TI graphing calculator. So let's go back down to the TI graphing calculator. Let's go to the home screen. So I want to quit. What this quit means, take me back to the home screen. That's in blue. So I need to click on the blue button over here. And then mode. You may have a different color. Sometimes they change the colors of the second buttons. So I want to type in 12 divided by 8. And what we want to do is that, in general, is attempt to convert that to a fraction. So to convert to a fraction in reduced form, we have a fraction, but we want to convert it to a fraction in reduced form. And this isn't going to work in theory 100% of the time, but it works a lot of the time. So 12 divided by 8, we want to click on the math key, and then you can see frac is highlighted there. So that means convert to a fraction. And then after this, I think the easiest way to do this is an enter, enter. Enter takes that command to the home screen. The next enter does what we want it to, converts to a fraction. So 12/8 is really 3/2. So if we go back up to our document, we get 3/2. Comma, 4 minus 8 is -4, over 8 is -1/2. So those are our other two zeros, 3/2 and -1/2. So we have our 3, our 3/2, and our -1/2. Any questions on this particular topic? Let's look at this topic in contrast. We are now looking at irrational zeros. Irrational zeros are real numbers which are not rational. So irrational means real numbers that are not rational. It's the opposite. And sometimes those can involve numbers with square root in it. So if we put this in our calculators, which we need to do because there's another way that the calculator can help us besides the table. Let's go ahead. I'm going to copy this down. H of x equals 7x cubed plus 19x squared plus 3x minus 5. Double checking. So let's go enter this because we're going to need this function entered regardless of which method we use to attempt to have the calculator help us. And it will help us here, but just not in the same way. So I'm going to go into y equals. Rather than trying to keep track of exponents and all of that, I'm just going to I'm going to have a fresh start and click on the clear button. So I'm going to do 7x Mountain Peak 3. Right arrow 19. Whoops, I forgot something. I forgot my plus sign this time. So let me go back over, use this. And this is helpful actually to see what to do. I use the left arrow key and then the delete. And I'm going to do it one more time. Left arrow key, delete. I forgot the plus sign, and that's probably going to happen to you at some point. Plus 19. 19. X squared. Right arrow. And then plus 3x and then minus 5. So 7x cubed plus 19x squared plus 3x minus 5. If we take a look at the table, just for fun, second graph, you can see in this column, it doesn't, where we're talking about 0, 1, 2, 3, 4, and so forth through 10, it doesn't look likely. If we back up and go the other way, so if we use this up arrow here, we're not seeing the number 0 in the y column at all. So we can't use the graphing calculator isn't helping us find a ZERO by using the table. So we need to use that topic that we learned where we construct a list of possible rational zeros. And fortunately, none of those got too long. So the numbers on top of this fraction here, what goes on top are the factors of -5 really, but you can just look at it as 5. The factors of 5 are 1 and 5. And then you just need to put plus or minuses out front. The numbers you want for the denominators are, the possible denominators are factors of this leading coefficient. That's why it's so important to write polynomials in descending power order. And this is 7. So those possibilities are 1 and 7 for the denominator. So I just wrote it like it had a denominator. So now we want to find all the possibilities. So let's just take 1 over 1 and then put a plus or minus out in front. Let's take 5 over 1 and put a plus or minus out in front. So I did both the 1 and 5 up here just over 1 first. To get the next two, let's use the 5. 5 over, or let's use the 7. So to get the next two, let's use the 7. 1 over 7, 1/7 with the plus or minus out in front. And then 5 over 7 with the plus or minus out in front. So I first did both of these over 1. And then I did both of these over 7. Any questions to this point? Now what we want to do is go back and look at the graphing calculator. I'm just writing down what I've got there. So let's go back. Now, what we want to do is you can look through the table. Which ones do you check and why? Is the question. We already have eliminated some of those. We've already eliminated -5. Let's eliminate -5 because if you look over here, we don't see the number 0 here. So one of our possibilities was -5, and we can eliminate it because we don't see the number 0 in the Y column. If we continue to go this way, you see -1 right here. That was one of our possibilities, but we don't have 0 over here. The number 0 over here. So I'm going to cross that one out. And if we keep going down this way, let's look for 1. We've got 1 as a possibility, but there's no number 0 over here. Can cross that one out. And if we keep going until we look for 5, let's do that. For the number 5, we don't have the number 0 over here, so we can cross that one out. So we need another way, and there is another way. So let me show that to you now. I've got to get back to the home screen. So that is a second mode. And I think, let me clear off this screen here too. I have showed you this method before. This is a method where we use vars. So let's go over this. So I want to click on vars. Right arrow over to yvars. And I like that this option is already selected. Vars is nice because it allows you to use function notation on the home screen of the calculator. So I'm just going to hit enter. And then that takes me to y1. We typed in our function 7x cubed. You can see it up here. This is the function that we're talking about. We already typed that in. And we want y1. And we typed it in y1. So we definitely want y1. So I'm just going to do an enter here. And that will take us to the home screen. Put y1 on the home screen, which is nice and big over here now. So y1, and this works with parentheses here. So if I want to check a number for a potential 0, I definitely want to have an open parenthesis. And let's check let's check positive 1/7. Let's check one that is not. So let's check -1/7. Let's check one possibility that is not a 0. -1 divided by 7. Closing parenthesis. And now we want to enter. So we did not get the number 0 over here. Let's try again. And we can repeat this entry to make it life easier. If you want to repeat an entry, it's entry right above the enter key. So it is that entry in my calculator is in blue, which matches the second button. So I'm going to go and click on the second button first, and then the enter key. And I want to change that. That's -1/7. I want to change that to -5/7. So if I want to change that to -5/7, we use the left arrow key, and I'm just going to type a 5 in place of that 1. That's -5/7. And enter. And I get a 0. So we get the number 0 here. So that means that this x inside the parentheses, -5/7, is a ZERO. So let me go back to this presentation. So we found that -5/7 is a 0. So we're going to put it through synthetic division. What are we going to use across the top? We've got all of our terms. So we're going to use 7, 19, 3, and -5. 7, 19, 3, and -5. So we're going to drop this straight down. We are then going to take this number out here and multiply it by what's at the bottom of the previous column, which is a 7. Those 7s cancel, and we get -5 here. Add straight down, 19 minus 5 is 14. We added, so we next need to multiply. -5/7 times what's at the bottom of the previous column, which is 14. That gave us, we could figure this out on our calculator. Okay, let's do it this way. 14 divided by 7 is 2. 2 times -5 is -10. So we add these straight down, get -7. Now we need to multiply. -5/7 times this -7. These 7s cancel, and we get negative times negative, which is a positive, and we have just left a 5. Add these straight down, we get the number 0. So we have confirmed that that is correct, not only by the graphing calculator, but by doing our synthetic division. So we are asked to find all the zeros. Just needed to double check. So our approach is to go through the factors. So we have a 0 of -5/7. By the factor theorem, x minus a -5/7, which is x plus 5/7, is a factor. The other factor are given by these coefficients right here. That's the other factor. It is a quadratic factor because we started with a cubic. So I wrote that factor down. 7x squared plus 14x minus 7. I looked and at this factor, and I saw 2 7s and thought to myself, well, 14 I can write as 7 times 2. So let's factor out a 7. It will make using the quadratic formula simpler. So factoring out a 7, this 7 came out front. We have just an x squared there, plus 7 went out. 14 is 7 times 2. The 7 went out front. The 2 stays. We get 2x minus this 7 is 7 times 1. 7 goes out front, the 1 stays. So what we are really looking for is we're looking for x's that make this y here equal to 0, which is why I put a 0 here, the number 0. We know what 0 comes from here. The 7 isn't playing a role. I could really divide both sides by 7 and get it out of the way if I wanted to. 0 divided by 7 would be 0. 7 divided by 7 would be 1. 1 times what's left is what's left. So I could really get it out of the way. So what we want to do is we know what 0 is associated with this factor. We want to take this factor, which is a quadratic factor, and set it equal to 0 and solve for x. So I just copied that over, x squared plus 2x minus 1. Our a is an understood 1. Our b is 2. Our c is negative 1. So we get x equals minus b, which is minus 2, plus or minus the square root of b, which is 2 squared, minus 4 times a, which is 1, times c, which is negative 1, all over 2a. So let's work inside the square root. 2 squared is 4. Minus times a minus is a plus 4. So that 4 plus 4 is 8. So we have square root of 8, which we can break down. 8 we can factor into 4 times 2. So we get square root of 4 times the square root of 2. The square root of 4 is 2. So we get 2 square root of 2. So now we have negative 2 plus or minus 2 square root of 2 all over 2 times 1, which is 2. So let's factor a 2 out of the top. Factor a 2 out here, out of this term. There is a negative sign left, but the negative really stands for negative 1. Plus or minus, this 2 went out front, so we're just left with square root of 2 divided by this 2. So we can cancel these 2's because 2 divided by 2 is 1. 1 times what's left is what's left. I know it's tempting to cancel these 2's. It doesn't work that way though, so you want to make sure you know why you're canceling. And so we're just, here are our other 2 zeros. Negative 1 plus square root of 2 and negative 1 minus square root of 2. So this is negative 1 plus square root of 2 and negative 1 minus square root of 2. And of course, we already identified this negative 5/7. So those are our 3 zeros. Any questions on this particular topic before we go on? Now you will notice we've got something going on here. This is our first quartic problem. So I want to show you it's not really difficult, I would say. I'm just seeing if we've got the same topic here. Zeros of a polynomial, irrational zeros. Okay. Zeros of a polynomial, irrational zeros. So this is the same topic as the last problem. So let's take a look at this. So we are going to look at this particular function. F of x equals 5x to the 4th plus 27x cubed minus 61x squared minus 33x plus 14. Let's copy that down. F of x equals 5x to the 4th plus 27x cubed minus 61x squared minus 33x plus 14. And I want to make sure I've got that copied down correctly. Let's go enter this in our calculator and see how to identify these two zeros. Luckily, one of these zeros is going to take us from a 4th degree polynomial, which is a quartic, down to a cubic. The other zero, this other nice zero, is going to take us from a cubic down to a quadratic. And we can use the quadratic formula to find the other two zeros. So y equals, use clear button to clear that out. So we have 5x raised to the 4th power raised to the 4th power. And then right arrow plus 27 x raised to the 3rd power minus 61x squared minus 61x squared. And then 33x minus 33x. And lastly, plus 14. And just let me take a look at this. So a little hard to see here, but I can see it over here. 5x to the 4th plus 27x cubed minus 61x squared minus 33x plus 14. Looks good. So I'm going to go into the graphing calculator. Before I do, though, I would think our table set is messed up a little bit. So I am going to go in and take a look at that. Second window. I want this to start at 0. So I'm just going to type in a 0 or 0 on my calculator, which either way it shows in red down here. So let's go to the table. It's second graph. And let's start looking. Does anybody see a 0? A Z-E-R-O? Anybody see a 0? Anybody identify a 0 for me? So what are we looking for? We're looking for an x where the y is equal to the number 0. So what is a 0 here?
2.
Yes. Yes, it is. Good. Very good. Now let's go backwards a little bit. If you see a 0, please let me know. Anybody see a 0?
-7.
Exactly. 2 and -7. Exactly. So that's good. Let's go back up here. So that's how we identify the 2 and the -7. Would save you lots of time. I remember learning this a long time ago. So this will save you a lot. So what we're going to do is we're going to use one 0 that we know of, or identified 0, to do synthetic division to take it from a 4th degree down to a 3rd degree, and the other 0 to take it from a 3rd degree down to a 2nd degree, which is a quadratic. So I would advise using the positive number first, so you don't have less negative numbers to deal with potentially. So let's put 2 here on the outside. Let's get our numbers across here, our coefficients, 4, 3, 2, 1, constant. So we want 5, 27, -61. And then -33, 14. And we do it the same way. Drop. Multiply. 2 times 5 is 10. 2 times 5, I wrote it down here if you need that. 2 times 5 is 10. And then add straight down. 27 plus 10 is 37. Multiply. 2 times 37. Wrote it down here. 2 times 37 is 74. Add straight down to get 13. Take 2 times 13 now. That gives us 26. Add straight down, get -7. 2 times -7 now. That's -14. We get 0. We expected to get the number 0. If we didn't, there would be something we did wrong. So next, normally, and you'll see this later, normally we can do this a little without writing down, saving a little bit of writing, and I'll show you that later. But I wanted to put these in here so you could see what I did. This encircled in blue are the coefficients of a cubic now. They're the coefficients of a cubic factor. So we want to use those, copy those numbers down exactly. This 537, this 13 -7, exactly right here. And now we are starting with a cubic, and this -7, which is a known 0, we are going to use to get it down to a quadratic. So we drop this first number. We then take this number, -7, and multiply it by what's at the bottom of the previous column, which is 5. -7 times 5 is -35. Add straight down and get 2. We then take the -7 and multiply by what's at the bottom of the previous column, which is a 2. And that is -14. Add straight down, get -1. We then take -7 and multiply it by what's at the bottom of the previous column, which is -1. -7 times -1, which is +7. Add straight down, and we get 0, which is what we needed to get. If we didn't get it, there'd be something wrong, because -7, we identified it as a 0, which means we must get a 0 output here, as well as here. So these were coefficients of a quartic, a 4th degree polynomial. We divided by x and got coefficients of a cubic, 1 degree less. We then divided by x again down here in this synthetic division table. We divided by this -7. So in a sense, and we reduced the cubic down to a quadratic. So these are coefficients of a quadratic expression. They are right here. A is 5, B is 2, C is a -1. So we are now going to find the other 2 zeros by using the quadratic formula. So they are, let's find them. X equals -b. Negative b is 2. Plus or minus the square root of b, which is 2 squared, minus 4 times a, which is 5, times c, which is -1, all over 2 times a, which is 5. So let's work with this Bradicand. What's inside the square root here? 2 squared is 4, minus a minus is a plus, 4 times 5 is 20. Adding those two together gives us 24. So we can take 24 and write it as 4 times 6. Square root of 4 is 2 times the square root of 6. 6 is 2 times 3. Those are both primes, so there's nothing we can do. So we just get 2 square root of 6. So we go over here, -2 plus or minus 2 square root of 6 all over 2 times 5, which is 10. Let's factor out a 2. We have a 2 in this term and in this term. Subtraction is just adding a negative, so you can really consider that a term too. So let's factor that 2 out. We're left with negative, but that's really -1. Plus or minus, we took this 2 all the way out front, square root of 6. 10 we can write as 2 times 5. That way we can cancel out these 2's. 2 divided by 2 is 1 times what's left is what's left. That is -1 plus or minus square root of 6 over 5. So we want to write these two zeros independently. -1 plus square root of 6 over 5. -1 plus square root of 6 over 5. And the other one is -1 minus square root of 6 over 5. -1 minus square root of 6 over 5. And of course our 2 and our -7. And all four of these zeros need to be separated by commas. Any questions on this? Okay, so let's go on. So we were looking at irrational zeros. We're now looking at complex zeros. I don't want to do the cubic because it's like what we've done before. And I'd rather focus on the quartic, I believe it is, in the complex for this particular topic. So let's look at the quartic. So let's look at this. Let's go to our graphing calculators and identify the zeros. Take a look at the time here. I think we have time to do this. So g of x is equal to 7x to the 4th minus 22x cubed minus 66x squared plus 7x minus 10. I'm just looking it over again just to make sure. Let's go to the graphing calculator and see if we can identify our zeros. So I'm going to click on y equals. This 5 that's flashing is a 7. And then we have 7x to the 4th. This might be a good time to try to just change what you need. So 7x to the 4th is good. I want to change that to a minus sign. I want this to be 22. X minus 22x cubed. And then I want to move along just by hitting the right arrow key. And then after the x cubed term, I have minus 66x squared. So I want to change that to a 6 and move along. And after the x squared, I want that to be plus. And then we actually just want 7x. So let me type a 7 there. And then I'm going to use a delete for that, del up here. And then minus 10. So you can do this if you're very careful in certain situations. Minus 10, so I want to change that 4 to a 0. And I'm going to double check. 7x to the 4th minus 22x cubed minus 66x squared plus 7x minus 10. So let's go into our table and see if we can identify two zeros. We have a quartic, so to get down to a quadratic, we need two zeros. One of them is going to take us down to a cubic, and the other is going to take us down to a quadratic. So I want to go to the table. It is above the graph button, so I need a second graph. Oh, what zero are we seeing already? That just popped up on the screen now. What's the zero? What's one of the zeros? Can somebody tell me? What's the
-2.
Yes, -2, exactly. And I have a hunch we need to go this direction, but let's go this direction and see if we can find another one. I'm using the down arrow key because I want to go down. I don't want to go too fast. Anybody else identify a 0? Now notice, as tempting as this is not a 0. When we use the word 0 in this context that we're talking about, it's an X coordinate. So we're actually looking in the Y column for where we get the number 0. And then we want to go straight over to the X coordinate. It's the X coordinate that is the ZERO. And in this case, it's 5. So -2 and 5 are our 2 zeros that will get us down to a quadratic. So -2 and 5 are zeros from graphing calculator. So I wrote let's start with the 5 better because it's positive. And let's write down all our coefficients. We have 7, -22 right here, -66, 7, and -10, -66, 7, and -10 right there. And let's see if we can just now have made the progression of being able to calculate our numbers. So this number gets dropped right there. Okay? Then what do I want to do? We want to multiply. So we take 5 times 7 to get 35. Add straight down to get 13. So that 13 goes right there. Then we take 5 times 13, which is 65. Add straight down to get -1. Then we take 5 times this -1, which is -5. Add straight down to get 2. Then we take 5 times this 2 to get 10, add straight down to get 0. That's what we needed. We needed the number 0 there. If we'd gotten anything else, we did something wrong. Because we identified using the graphing calculator that 5 is a ZERO. Now, so what I did is I made this look like a long division tab notation, and I put the -2 out in front, the other 0 that's known. And I split off this last number here with a little vertical line. This is another reason why it's really good to use that. So I am now just going to use these numbers and do synthetic division. Drop, get 7. Multiply, -2 times 7 is -14. Add straight down, 13 minus 14 is -1. Multiply, -2 times -1, +2. Add straight down, -1 plus 2 is +1. -2 times 1 is -2. Add straight down, we get 0. And we are down to a quadratic. We started as a quartic. We did this division. That took us to a cubic. We did this division. That takes us to a quadratic. Those are the coefficients of a quadratic expression. They are also used in the quadratic formula. This is the A, the B, the C. This is the X term, or sorry, this is the X squared term. This is the X term. This is the constant term of a quadratic. So we've done this before. X equals -b. So X equals -b is a -1. So there's a negative in the formula. And then we have a -1, negative times negative makes that a +1. Plus or minus the square root b, -1 squared minus 4 times a, which is 7, times c, which is 1, all over 2 times a, which is 7. So what we have here is negative 1 squared. That's negative 1 times negative 1, which is positive 1, minus 4 times 7, 28. 1 minus 28, negative 27. So that negative sign is really negative 1. So this is square root. That negative sign we can write as square root of negative 1. This 27 is 9 times 3. So that would give us square root of 9 times the square root of 3. I, the imaginary unit, is equal to the square root of negative 1. So this I, right, this square root of negative 1 is I. The square root of is 3. And then we can't do anything to the square root of 3, so we just write it down again. And usually what we do is we put the number out in front and the real number out in front. So let's do that. 3, so we get 3i square root of 3. So we have 1 plus or minus. This we take out and replace it by 3i square root of 3. And I copy down the 1 plus or minus. And in the denominator, we have 2 times 7, which is 14. These are our other two zeros. So one of the zeros is 1 plus 3i square root of 3 over 14, which is here. The other one is same thing exactly, but with a minus sign in the middle. So that I've had to write up there because I ran out of room. Any questions on this particular topic? So let's take a look at this one. Let me see what I want to do here. I've got a little bit of time left. So this one is use a given zero to write a polynomial as a product of linear factors. Yeah, that's a cubic. I think I want to do that one because I marked it up in the other class. Yeah, this one, I think we've done one like that. We've done those. So I think we're good on that one. So let's do this one. Using a given zero to write a polynomial as a product of linear factors. So that's that first problem of the day. We wanted to write linear factors because that was the written work required problem, which required you to write linear factors. This problem requires us to write linear factors. For the polynomial below, 1 is a 0. Here's our polynomial. Express f of x as a product of linear factors. And we're given 1 is a 0. So I just copied it down again here. We know 1 is a 0, goes out here. Our coefficients go in here, and we've got them all. So we've got 1, negative 7, 24, negative 18. So let's do our synthetic division. Drop, multiply, 1 times 1 is 1, add, get negative 6, multiply 1 times negative 6 is negative 6, 24 minus 6 is 18, multiply 1 times 18, 18, negative 18 plus 18 is this 0, which we expected to get. So we started with the cubic. We went through synthetic division once. That means we divided by x. So we get 3x's divided by x, which leaves 2x's, which means we have x squared, like this. So these are if we put our vertical line here, these are the a, b, and c in the quadratic formula. I could also take the polynomial, just to make sure you understand, and write it as x minus the 0, 1 times this quadratic factor. It would be 1 times x squared, which is x squared, minus 6x plus 18. And it's this factor that we want to use, set it equal to 0, and then use the quadratic formula. So let's use the quadratic formula. And we've got our a, b, and c here. So x equals negative b, negative 6, plus or minus square root, all of this, b, negative 6 in parentheses squared, minus 4 times a, which is 1, times c, which is 18, all over 2 times a, which is 1. So let's clean this up. Negative 6 times negative 6 is positive 36, minus 4 times 18 turns out to be 72. 36 minus 72 is negative 36. Square root of a negative, that negative is really negative 1. The square root of negative 1 is I. The square root of 36 is 6. So this radicand, this discriminant here, what's inside the radical, whatever you want to call it, is 6, is really turns out to be 6. This square root here turns out to be 6i. So that gives us negative of a negative, which is a positive 6 right here, plus or minus 6i all over 2. We can then factor out a 2. It seems to be a lot of that going on today. If we take this 6 is 2 times 3. So if we take the 2 out front, we're left with a 3. Plus or minus, this 6 is 2 times 3. The 2 goes out front, we're left with a 3i. And then we can cancel these 2's. 2 divided by 2 is 1, times what's left is what's left. Those are our other 2 zeros. But keep in mind, this problem wanted the factors. So let's look up here. I wrote it down here so we could see it closer. We didn't have to go scrolling back and forth. The first 0 that we actually were told, right, was 1. So x minus that 0 is a factor. X, we're going to have another factor. So we need a set of parentheses for the factor. So x minus our second 0 that we found is going to be what we need. But when we put this 3 plus 3i in, we need to put parentheses around it because it is just like that, like we see it there, because it has 2 terms. So we have to have one set of parentheses, the outside set, because it's a factor. The inside set we have to have for around just the 0. Because this x minus means this is how we can what the factor theorem tells us. X minus a 0 is a factor. So we also want to show this x minus like that, and then we just put parentheses around the 0. So you have 2 sets of parentheses when you're talking about 2 terms in your zeros. You've got the outside set for the factors, the inside set for the 0. Same thing over here, x minus the other 0, which is the minus 1 here, which is 3 minus 3i. We want the outside set for the factor, the inside set for the 0. And that is the answer. So that I took this, made it to go all the way up here into the answer box. Any questions about this particular topic? So I will come up there now and say my goodbyes. And have a nice weekend. Take care. I love you all. If you need some help, reach out to me. I'll do my best to find a time we can meet. Take care. See you. Actually, I need to wish you all a happy Thanksgiving too, because you're going to take a test next Tuesday. Happy Thanksgiving. Please stay safe. There's a lot going on out there. So feel free to leave if you want to talk and chat, stay and chat for a moment. You're welcome to chat for as long as you want. I've got some time now. Take care. Feel free to leave now. Goodbye for now. It's cute. So cute. Anybody who's left? Courtney, Guillermo, Logan, Richard, do you have any questions or comments, or is there anything I can do to help you?
No, thank you.
Okay. Well, have a nice break next week after the test.
All right, you too.
Okay, bye.
Bye.
Richard, Guillermo, is there anything I can do to help you? Okay, I'm going to leave the conference now.